So we can figure out the area of these two faces. Well, the front face is L times H, and we have two of them. And the top and bottom are W times L. So we have two of those. And the right side is W times H, if we wanted to put H there just to make sure we see. And there's our formula. And if we identified it over here, this would be my left side, this would be my right side, this would be my front, this would be my bottom, this would be the back of this prism, and this would end up being the top when it's all folded. And we would go ahead and we could figure out the area given now that it's flat. So again, the general idea is there's no really set formula for surface area of a prism. Just figure out the area of all the faces and recognize that in a rectangular prism they double up, and in other prisms you have to be a bit more careful. Okay, the other shape you learned is a cylinder. And cylinders are really nice simple shapes that really only have these two things going for them. They have a radius and they have a height. So a nice way to think about a cylinder is something like a toilet roll. Now the toilet roll doesn't have tops and bottoms, but you know they're circular, and we could figure out the area if we wanted to. So again, in this little area is going to be surface area is going to be the top and the bottom plus the outside, and what that's known as is the lateral side. Lateral side. So we know a formula for the top. Top's just a circle. And the formula for a circle, the area of a circle, is pi r squared. And again, we have two of them. And in order to figure out how big the lateral side is, the outside, what you need to understand is, well, one of the dimensions is definitely h. And if you remember back from grade 9, the other dimension is you consider how long it is, and it's that distance around, and that, of course, is circumference. So the circumference of a circle is 2 pi r. We could consider that L, the length of this thing, and then the other dimension is h. And if we look at that on the right here, well, those are our two circles if we exploded. And we're going to do a quick little activity in class to see, hey, how come a cylinder unrolls into a flat piece? But this could be considered the circumference of that big lateral area, and this dimension would be our height. So again, a net diagram. Okay, and that's all old stuff from last year, but it actually does relate to what we're going to do today. So let's have a look at some new shapes maybe. I'm sure you know what these things are, but we're going to actually look at them now. So again, the one key thing to understand is in a pyramid, you have a shape that has a base and then it has triangular sides. It'll always have triangular sides. The very top is the apex. Whatever shape the base is, that's the kind of pyramid it is. So this one is a rectangular prism. It might be a square prism. We don't exactly know. And if we want to figure out the surface area of this thing, well, again, it's this idea there's not a set formula. It is this idea of, well, I need to figure out the area of the faces and the area of the base. So the area of the base plus the area of the faces. Now, much like a rectangular prism, what we should realize is opposite faces, opposite triangular faces are the same, but all four faces don't have to necessarily be the same. So I'm going to say front, back, right, left. So in order to figure out the surface area, we're going to have to figure out the area of the right and left face. and you'll see what I mean when we do some examples, plus the area of the front and back face. Now, in order to do that, what you have to realize is that those are triangles, and the definition for the area of a triangle is 1/2 base times height. And what we need to realize is it's the height of the face right there. And what this is called is, this is not the height of the pyramid. The height of the pyramid is the perpendicular one right in the middle. What this is called is the slant height of a face. And these slant heights might actually be different. So here's another slant height. And the black one may be different than the red one. Again, left, right, front, and back. So when we go ahead and develop our formula for this, I'm going to label these. I'm going to label my diagram. Let's call this side L and this side W. And for right now, we're just going to treat this slant height, I'll call it S, as the same. So for a simple example, we're just going to say for right now these are exactly the same. And in figuring out my surface area, well, the area of the base is L times W. And the area of, say, the right-sided face, triangular face, is going to be 1/2 base, which I'm calling the width, times the slant height. But then remember, we have two of those. So that doesn't look very nice, but the 2 and the 1/2 cancel each other out. And similarly, this idea of I have a front and a back, and now my base dimension is L. And again, I'm going to call it the same slant height, just to make it easy. And on our net diagram over here, well, what that might look like is, well, this is L, one of the dimensions of my base, and this is W, and this is the slant height. So again, notice that the slant height is the height of a triangular face, not the height of a pyramid. In putting the height of the pyramid on, the height of the pyramid is the perpendicular distance from the apex to the base. So that distance there, that is the height of the pyramid when we run into those examples. Okay, a cone. Again, we've all seen cones. And again, notice that cones have a height, just like how tall is the cone. But what they also have is they have the slant height. So this is the height of the cone, and this is the slant height of the lateral area. So if we were going to figure out the surface area of this thing, well, surface area is equal to the area of the base plus the lateral area. And again, in this picture above, we're going to do something like this in class. This picture right above shows that picture. And the area of this thing, well, the area of the base is a circle, it's pi r squared. And the lateral area is going to turn out to be that, pi rs. Finally, our last shape is a sphere. Spheres have a radius, and the surface area is equal to 4 pi r squared. Okay, so there's our formulas, and those are all written down on your blue sheet that I gave you the other day. And again, you really need that blue sheet. You don't need to memorize formulas, you just have to know what you're doing. So let's look at a quick couple of examples. And really what we have to be able to do in calculating things is, if I give you dimensions, you can tell me the surface area, and sometimes I might give you the surface area and you have to come up with a dimension. So here's our first question. A right rectangular pyramid has a base of 8 feet by 10 feet. It is rectangular, not square, and has a height of 16 feet. And what we want to do is calculate the surface area. So a really good thing to do all the time is sketch a quick little picture. So you don't have to be perfect, but if you can draw it as accurately as you can, then you're going to make your brain a lot happier. So here's my pyramid, and after I've done my drawing, I'm going to label everything I know. So I'm going to call this my 8-foot dimension of my base, and I'm going to call this my 10-foot dimension of my base. And again, the height of the pyramid, again, height is not slant height. The height of the pyramid is the perpendicular distance, so meets at 90 degrees, from the very top of the pyramid to the base. So here's what we have. And again, another good thing to do when you're doing these sort of calculations is write down your formula right off the bat. So the surface area is equal to the area of the base, and I'm just going to call that area of base, plus 2 times the area of the front and back faces, triangular faces, plus 2 times the area of the right and left faces. Now the area of the base is straightforward. I'll just make a little note over here. The area of the base is equal to 10 times 8, which is 80 square feet. Really straightforward calculation. The triangular faces are a little bit more challenging because in order to figure out what the area of one particular face is, say this one right here, and the one on the back, what I have to know is I have to know how long that red line is. And I hope you guys realize right now that, well, that line has to be bigger than 16, because 16 is perpendicular and this is slanted. And the other thing I hope you recognize right now is, in order to figure that out, you have to use good old-fashioned Pythagoras. So let's do this calculation. We'll keep it in red. Remember, this is the slant height of my 2 triangular faces that I'm calling front and back. So this is just my little notation. So in order to figure out the area of those 2 faces, I have to know how long that red line is. I already know the base. So all I need to know is how long that red line is. And what I've just drawn is I've just drawn a right triangle. So let me draw that right triangle. Here it is right here. And what we know is, I'm going to call this A. So what I know is, I know that the height of that is 16, and I know that the base, this distance here, is the same as that distance there, and that distance there is half of 8. So what I know is, I know that. And what that allows me to do is to use Pythagoras and figure out how long that red line is. Now, that has to be the longest side, right? So when I do my calculation, I know that 4 squared I know that 4 squared plus 16 squared is equal to, again, I'm calling it a squared. It doesn't matter what we call it. 16 plus 256 is equal to a squared. A squared is equal to 272. And remember, to undo a square, we do a square root. And what we end up with is a is equal to 16.4924. Now, any intermediate calculation for us in provincial exam should be done to 4 decimal places. in order to figure out, okay, let's finish this one off. So now, in order to figure out the area of that triangular face and the one on the back, and remember what I'm calling it. I'm calling it area of front and back. Well, that's equal to 2, because there's two faces, times 1/2 base, and the base of this one is 10, times the height, which is 16.4924. And when we do that calculation, well, actually, I haven't figured it out. You get a number, and we'll plug that number in. Okay, let's do the second one then. Okay, this one, I want to figure out that green line. How long is the green line? And again, what I hope you recognize is when you connect that to the perpendicular, you end up with a right triangle. So I'll keep in green mode. And we're going to end up with, well, I'll call it B this time. I want to figure out a different slant height. And the height is 6. And again, what I hope you realize is that this base distance here is that distance there. So look at the triangle in the pyramid and look at this one, and what we end up with is, well, this has to be 5. And again, back to Pythagoras, 5 squared plus 16 squared is equal to b squared. And I'm not going to do all that work because we just did it right there, but when you do all that work, you get this. And b turns out to be, to 4 decimal places, because it's not our final answer, 16.7631. And that's great, because now what I can do is I can figure out the area. Remember, I'm calling it the right and the left. You can call it whatever you want, whatever makes sense to you. That's equal to, well, there's 2 of them, times the formula for a triangle 1/2 base. Remember, the base of this one is 8. It's connected to that green line, times 16.7631. Now again, if you wanted to do those, you could go ahead and do it. But what I did in my notes is I just put all these things together. So I would end up with the total area. So I'm going to call it surface area total. Well, we know that's equal to 80, the area of the base, plus this thing right here, whatever that is, you can do it on your calculator, plus this thing right here. And when you punch all those buttons on your calculator, to the nearest square foot, you get 379 square feet. So again, a relatively simple little problem that you have to be really, really careful with. I guess the simplest pyramid calculations are when you have a square base. So remember, slant heights are not the same. You have to be really, really careful and follow through with your calculations. Okay, let's do one more. A lot simpler. Maybe should have started off with this one. A right cone has a base radius of 2 meters and a height of 7 meters. Calculate the surface area. So again, same idea as above. A quick little sketch. Here's my quick little sketch. Doesn't have to be perfect. There's my cone. And what my cone has is, it has a radius of 2 meters, and it has a height, remember height, not slant height, of 7 meters. Formula for surface area is pi r squared h plus, pi r squared plus pi rs. Now if you look at this, well, what do we know? We know pi. Pi is just a number. We know r. It's 2. Again, over here we know pi. Over here we know r. So in order to answer this question, what we have to know is s. What we have to know is that s represents the slant height of that cone. And again, surprise, surprise, we're going to need to use Pythagoras in order to figure out the slant height of the cone. So let's just do it right here. Can I draw my my right triangle? There's my base, there's my height, and 7 squared plus 2 squared is equal to s squared. 49 plus 4 is equal to s squared. 53 is equal to s squared, and s is equal to 4 decimal places, 7.2801. Because again, remember, you undo a square root with a square. And now, given that we've done that, we have all the information, and now we can just plug our numbers into the appropriate spot, and as long as we put them into the appropriate spot, you can't help but being right. And when you finally do that, you get 53.3 feet squared. So a little bit of algebra there, a little bit of manipulation there. And what I'm going to ask you to do is, if you have any problems with anything, especially the calculations, the formulas, not such a big deal. Remember, you don't have to memorize them. But if you have any troubles with any of these, any specific questions, be as specific what you can, what I want you to do is to tweet this hashtag. And again, be specific as possible. And that's how we'll start next class.